Drill straight down through your floor, keep going, and eventually you'd pop out the other side of the planet, blinking in the sunlight, somewhere on the far side of the world. That's the dream, the childhood tunnel straight through the Earth, in one side and out the other. The truth is so much stranger than coming out the other side, because if we actually carved that tunnel and you jumped in, the planet would do something to your body that almost nobody guesses, and the other side isn't where you'd end up at all. So let's build it. Let's ignore, just for a moment, every law of physics screaming, "We can't," and jump in. First, the bad news, and it's almost embarrassing. We have never come close. The deepest hole humanity has ever made is a research borehole in northern Russia called Kola. It took about 20 years of drilling to reach just over 12 kilometers down. And here's the thing. The planet is around 12,700 kilometers across. So after 20 years of our very best effort, we made it roughly 1,000th of the way. If the Earth were the size of a basketball, that record-breaking hole wouldn't even scratch through the paint. We have never once dug our way out of the crust. Why did they stop? The rock got hot, around 180 degrees, and at that heat, the stone stopped behaving like stone. It went soft, almost gooey, closing in around the drill faster than they could cut. The planet basically swallowed the bit, and that hole, after all that work, is barely the width of a dinner plate. So let's be honest about the real walls in our way. It isn't the digging, it's what waits in the middle. At the center of the Earth, the temperature is somewhere around 6,000 degrees, about as hot as the glowing surface of the sun, and the pressure down there is more than 3 million times the gentle weight of air pressing on you right now. No drill, no metal, no material we know how to make survives either one. For anything real, the trip ends almost before it starts. But this is a thought experiment, so let's cheat completely. Our tunnel is indestructible, perfectly cool, with the air sucked out so nothing slows us down. It runs straight through the dead center, pole to pole. You step to the edge, look down into the dark, and you step off. Now the fun begins. You don't drift, you fall, and you keep speeding up, faster and faster, because gravity is pulling you toward the center the entire way down. By the time you reach the middle of the Earth, you'd be moving at something like 8 kilometers every second. That's roughly 28,000 kilometers an hour, faster than a rifle bullet. You would be falling at almost the exact speed the space station uses to orbit the planet, and then you hit the center. That's where everything you assumed quietly falls apart. Here's the question. At the very middle of the Earth, which way is down? Think about it. Below your feet is more Earth. Above your head is more Earth. To your left, your right, in front, behind, in every direction you point, there's an equal amount of planet pulling you toward it. And all those pulls, from all those directions, cancel each other out perfectly. This is the part people never see coming. At the center of the Earth, you would be completely weightless, floating. Not because gravity switched off, but because it's tugging you equally hard in every direction at once, so the total adds up to nothing. You are the filling in a sandwich, and the bread is the entire planet, squeezing in from all sides with exactly equal force. No side wins, so you just hang there, in the middle of everything. Sit with that for a second. Honestly, this might be the single most counterintuitive fact about the ground beneath our feet. There's a beautiful rule under all this, worked out by Isaac Newton centuries ago. As you fall past each layer, all the material now above you, the shell you've already dropped through, stops pulling on you completely. Every bit of it cancels. Only the ball of planet still beneath you keeps tugging. So the deeper you go, the smaller that ball, the weaker the pull, until at the center there's nothing left below you, and gravity fades to zero. Gentle at the start, gone at the heart. But you don't arrive gently. You're racing through at 8 kilometers a second, so you overshoot. You blow past the center and start climbing the far side, with gravity now behind you, slowing you down. You rise and slow and rise until, for one single instant, your fingertips reach the far opening on the opposite side of the world with exactly 0 speed left. And then you fall back in, and you do it all again, back and forth, forever. A human pendulum swinging through the core of the planet. How long is one trip all the way through? About 42 minutes, pole to pole, in less than a school class. And here's the detail that delighted physicists. It barely matters where you dig the tunnel, straight through the center, or slanted like a cord from one city to another far away, the journey still takes roughly the same 42 minutes. Gravity alone delivers you, end to end, in about 3/4 of an hour. No engine, no fuel, just falling. People half-seriously call it the gravity train. I still find that hard to fully believe. Now, reality check. We sucked the air out to make this work. Put the air back, and each swing gets a little smaller, your speed bleeding into the wind until you stop overshooting and simply settle, floating, weightless, at the exact center of the Earth. So would you pop out the far side? You wouldn't. You'd end up stuck in the middle, hanging in the heart of the planet. Which, frankly, is a stranger fate than I expected. And that far exit was a fantasy anyway. Dig straight down from almost anywhere on land, and you'd surface in the middle of an open ocean, nowhere near the country you pictured. And the spinning planet meddles too. The top of your tunnel moves faster than the bottom, so unless you dig pole to pole, the spin shoves you sideways into the wall. The same invisible nudge that curls hurricanes and swirls a storm. That's why our tunnel ran through the poles. And what would you pass through on the way? First, the thin crust. Then the mantle, hot rock that over millions of years flows like impossibly thick tar. Then an ocean of liquid metal, mostly iron, churning around the core. And that churning ocean is the reason a compass needle swings north, and the reason we're shielded from the harsh weather of space at all. And finally, the inner core, a solid ball of metal about the size of Pluto, hotter than the metal around it, yet solid anyway, because the pressure is so immense it refuses to let the iron melt. That inner core hides the strangest secret of all, and this one we're still arguing about. The leading idea, from very recent measurements, is that the solid heart of our planet doesn't turn in perfect lockstep with the rest of it. It drifts a little faster, then a little slower, on a cycle that may run around 70 years. The very center of your world might be quietly turning the other way as you watch this. We don't actually know for sure yet. If you can picture the core of the Earth slowly reversing beneath your feet, I'd love to read how you hold that image down below, because I keep trying and I keep coming up short. Here's where it all lands. We've stood on this planet our whole lives, certain we understand down. But down isn't some fixed direction in the universe. It's just the way the Earth happens to pull. Walk to the center, and down dissolves into every direction at once, until it means nothing at all. The thing we trust most, the solid pull beneath our feet, turns out to be a local arrangement that simply runs out at the middle. That's the kind of question we chase here at Briefly Science. The ones where the most familiar thing in your life, the ground itself, turns out to be hiding something wild at its core. If this made you look at the floor a little differently, subscribe and come with us. And tell us, what completely ordinary thing do you suspect is secretly strange? The best ones become the next story. The Earth is mostly a mystery we happen to be standing on top of. A glowing heart of iron, an ocean of churning metal, a pull that points everywhere and nowhere, all of it under your shoes right now, holding you gently in place. Down was never the bottom. It was always the center, calling us home.